Welcome to another exciting journey into the world of science with Adeptis Academy. Today we're diving into something extremely important in today's world, yet often goes unnoticed. Have you ever stopped to think about how amazing electricity is? It's one of those things we take for granted, but it's truly fascinating when you start to explore it. It's the silent force that powers our world, from the lights in our homes to the phones in our pockets. Imagine a day without electricity. No lights, no internet, no gadgets. It's hard to even picture, right? We use it every day, but how much do we really know about it? How does it work? Where does it come from? These are questions that might not cross our minds often, but they're incredibly important. Electricity might seem mysterious, but don't worry, it's not magic. It's a natural phenomenon that we have learned to harness and use in countless ways. It's all about the way tiny particles move and interact. These particles, called electrons, are the key players in the story of electricity. Once you understand the basics, you'll see electricity everywhere you look. From the streetlights that guide us home at night to the appliances that make our lives easier, electricity is truly omnipresent. And you'll be able to appreciate just how incredible it really is. It's not just about convenience. It's about the marvel of science and human ingenuity. We're going on an electrifying adventure. From the basics of how electricity is generated to the complex systems that deliver it to our homes, we'll cover it all. But that's not all. We'll also see how electricity interconnects with electronics, computers, and engineering. These fields rely on electricity to function and innovate, driving the technology that shapes our modern world. From the microchips in our computers to the circuits in our smartphones, electricity is the backbone of modern electronics. Engineers harness this power to create the devices and systems that keep us connected and productive. Fasten your seatbelts, because we're about to dive into the world of electrons, circuits, and the amazing power of electricity. By the end of this journey, you'll have a newfound appreciation for the energy that powers our lives and the technology that drives our future. To understand electricity, we need to zoom in on atoms. Atoms are like tiny building blocks that make up everything around us. Inside an atom, even tinier particles are buzzing around. One of these particles is the electron. Electrons are super important because they carry a negative charge. Think of it like this. Electrons are like tiny little magnets, and they can flow from one place to another. This flow of electrons is what we call electricity. So when you flip a light switch, you're actually creating a path for electrons to flow through wires. Pretty cool, right? Now let's talk about the three musketeers of electricity: voltage, current, and resistance. These three elements are fundamental to understanding how electrical systems work and are the backbone of any electrical circuit. These guys are always hanging out together, and they're essential for making electricity work. Without them, we wouldn't be able to power our homes, charge our devices, or even light up a simple bulb. Voltage is like the pressure that pushes electrons along. It's the force that drives the electrical current through the circuit, much like how water pressure pushes water through pipes. Think of it like water pressure in a hose. The higher the voltage, the stronger the push. This push is what enables the electrons to move through the circuit, powering everything from small gadgets to large appliances. Current is the flow of electrons, like the water flowing through the hose. It's the actual movement of the electrons that delivers energy to the components in the circuit. More electrons moving means a stronger current. This flow is measured in amperes, and it's crucial for determining how much power is being delivered. Resistance is anything that slows down the flow of electrons, like a kink in the hose. It opposes the current and can affect how much current flows through the circuit. Materials like rubber have high resistance, while materials like copper have low resistance. This difference in resistance is what makes some materials better conductors than others. These three amigos work together to make all sorts of amazing things happen with electricity. From powering our homes to running complex machinery, voltage, current, and resistance are at the heart of it all. Understanding how they interact is key to mastering the world of electronics. Sometimes it's easier to understand electricity by comparing it to something we're more familiar with, like water flowing through a pipe. This analogy can help us grasp the basic principles of how electricity behaves in a circuit. Imagine a water tower connected to a system of pipes. The water tower stores water at a certain height, creating potential energy due to gravity. The water in the tower has potential energy because of its height, just like a battery has voltage. Voltage is the electrical potential energy per unit charge, similar to how the height of the water tower determines the potential energy of the water. When you open a faucet, the water flows through the pipes, just like electricity flows through wires. The faucet controls the flow of water, much like a switch controls the flow of electricity in a circuit. The amount of water flowing is like the current. In electrical terms, current is the rate at which electric charge flows through a conductor. If the pipe is narrow or has a kink in it, the water flow will be restricted. This restriction is similar to resistance in an electrical circuit, which opposes the flow of current. This is like resistance in an electrical circuit. Resistance determines how much current will flow for a given voltage, just as the kink in the hose determines how much water will flow for a given pressure. See? The water flow analogy helps us visualize how electricity works in a simple and easy-to-understand way. By comparing the flow of water to the flow of electricity, we can better understand concepts like voltage, current, and resistance, making the principles of electricity more accessible and less intimidating. Throughout history, brilliant minds have been captivated by electricity. Two of the biggest names you might recognize are Thomas Edison and Nikola Tesla. Edison, the inventor of the light bulb, was a master of direct current, or DC, where electrons flow in one direction. He brought light to our homes and changed the way we live. Tesla, a visionary genius, championed alternating current, or AC, where electrons change direction constantly. AC is more efficient for long-distance transmission and powers most of our homes today. These pioneers, along with countless others, paved the way for our modern electrical world. Electricity is everywhere, powering everything we rely on. Our homes are filled with electrical appliances, from refrigerators that keep our food fresh to computers that connect us to the world. Hospitals rely on electricity for life-saving equipment, and transportation systems wouldn't function without it. Electricity also plays a crucial role in communication. Our phones, computers, and televisions all rely on electricity to transmit information at lightning speed. It's hard to imagine life without electricity. It's become an essential part of our existence. The future of electricity is brighter than ever. Scientists and engineers are constantly working on new ways to generate, store, and use electricity more efficiently and sustainably. Renewable energy sources like solar and wind power are becoming increasingly important as we move towards a cleaner energy future. Electric cars are gaining popularity, reducing our reliance on fossil fuels. Nanotechnology and quantum computing are also opening up exciting possibilities for the future of electricity. We're on the cusp of a new era of technological advancements powered by this amazing force. The possibilities are limitless. Electricity is powerful and essential, but it's important to remember that it can also be dangerous if not handled properly. Always follow safety guidelines when using electrical appliances. Never touch exposed wires, and be careful around water when using electricity. Teach children about electrical safety from a young age, and make sure they know how to stay safe around electricity. Remember, safety first. Congratulations, science explorers! You've unlocked the secrets of electricity and gained a newfound appreciation for this incredible force that powers our world. But our journey doesn't end here. The world of science is full of wonders waiting to be discovered. So stay curious, keep asking questions, and never stop exploring the amazing world around you. And always remember, just like electricity, you have the power to make a difference in the world.